Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, the thing people get most wrong about modern AI, they still call it a language model, when the frontier ones happily read your screenshot, watch your video, and listen to your voice. And the trick that makes it work is almost embarrassingly simple.
Okay, that's the bit I never understood. A language model is built to handle text, words, tokens, the whole next token thing. How on earth do you feed it a photograph? Those are pixels. There's no obvious place to plug them in.
Right. And the lazy guess is it runs some text recognition step first and just reads off the words. That's not it. A vision model has three pieces bolted together. First, a vision encoder. It takes the image and chops it into a grid of little tiles called patches, say 14 by 14 pixels each. Every patch gets turned into a vector, a list of numbers.
So it's doing to the image exactly what tokenization does to a sentence, cutting it into pieces and turning each piece into a number.
That's precisely the analogy, and it's exact, not loose. Text gets split into subword tokens, and image gets split into patch tokens. Same move, different raw material. Then the second piece, a small adapter called a projection layer, takes those patch vectors and maps them into the very same space the language model already uses for word tokens.
So by the time the image reaches the language model, it doesn't look like an image at all. It looks like more tokens, indistinguishable from words as far as the model is concerned.
You just said the whole lesson. To the language model, an image is simply more tokens, sitting in the same embedding space as your text, in one stream. It reads image tokens and word tokens side by side and does the usual transformer thing. And the beautiful part, audio is the same story. Encode short slices of sound into tokens. Video is just images over time. Everything becomes tokens.
Which means if everything is tokens, everything is priced in tokens. And I have a feeling that's where the bill gets nasty.
That's the catch. And it's the single most important practical fact here. Because an image becomes tokens, resolution drives cost. More pixels means more patches, which means more tokens, which means more money and more waiting. And high-res images often get tiled, sliced into multiple crops, each crop adding its own block of tokens.
Give me a number. How bad does it actually get?
Here's the shape of it. With a typical tiled encoder, a 500-pixel image might cost a few hundred tokens. Double the resolution to 1,000 pixels, and you don't double the cost. You roughly quadruple the tiles and the token bill with them. It's a square law. So one high-resolution photo can cost you as many tokens as pages of text, and a handful of images can blow your whole context window on their own.
So the obvious habit, and tell me if this is the big lever, is to send the smallest image that still answers the question and only go high detail when you genuinely need to read the fine print.
That is the single biggest lever on multimodal cost. Full stop. Downscale before you send. Reserve high detail mode for when you truly need to read small text or pick out a tiny object. Most people send a giant image out of habit and pay for resolution the model never needed.
Let me turn to where this actually earns its keep. What are people building with it?
Documents are the killer one. For PDFs and scans, these vision models now often beat traditional text recognition tools because they don't just read characters, they read layout, tables, even handwriting, all in context. The whole agentic document parsing world is built on this. Then video. You sample a handful of frames. You almost never feed every frame. And you pair them with the transcript for the audio.
And audio itself? Is that always speech-to-text first?
Two flavors. Either a speech-to-text front-end feeds a normal text model. Simple, loses the tone. Or a natively multimodal model ingests the audio tokens directly, so it can hear tone of voice and non-speech cues. A sigh, a laugh. And here's a feature people miss. Many of these models can point. They'll hand back bounding boxes. The button is here. The total is in this box. Not just a description. That's what makes screen agents and document extraction actually work.
So if I had to compress it, The deep idea is that vision didn't get bolted on with some special new machinery. They found a way to make pixels speak the language the model already understood.
That's exactly right. And it's why this matters. Turn the image into tokens in the text space, and the language model you already trust handles the rest. Which is also why treating multimodal as some exotic niche is a mistake. In 2026, it's the default surface for new products. Document understanding, screen agents, video summaries, voice interfaces. That's where the building is happening.
One sentence to walk away with a
An image is just more tokens, so it obeys the same economics as text. And your biggest win is sending the smallest picture that still answers the question.
pixels taught to speak token. That's the Datarekha audio guide. See you in the next one.